Hi everyone, this is Mohit. Welcome back to my YouTube channel. So this is the 6th day in our 60 days video series on statistics for data science, guys. In this video series, so far, we have set up the foundations for statistics for data science, as well as we have started our first type of statistical analysis, that is descriptive statistics, right? We have already covered first type of descriptive measures. Those are central tendency measures like mean, median and mode. We have covered them from theoretical as well as the practical point of view. We have seen how we can calculate them in Excel. So if you have not watched those videos, please go and watch them first. In this video, we are going to start with the second type of measures we have in descriptive statistics. Those are measure of spread. Specifically, we are going to cover range, standard deviation, variance, and interquartile range. These are very frequently used measure of spreads, guys. So don't miss out this. So watch till the end, guys. And one request, if you are new to this channel, please subscribe the channel and hit the bell icon so that you do not miss out any of the video, guys. So without wasting more time, let's get started with our today's video. Before going into all the different measures of spread which we have, guys, let's first understand what is the requirement. Despite having mean, median and mode, why do we need other measures? Right? So let's understand this requirement using a simple example. Let's say we have two different brands of TVs, right? So let's say this is Sony TV sales for 5 days, right? Similarly, this is for Samsung's TVs sale, right? So for 5 days. Now we have these two data sets. Now if you look at these two data sets carefully, the values are quite different in both the data set. If you calculate the mean of these two data sets, we will have the same value, right? If you calculate the mean for this data set, the average is 10. And for this data set as well, we have the average value 10. Now, central measure or the central tendency measures mean is giving you the same result. But if you look at the data, do you think these two are very similar data set? Definitely not, right? Here, the values are very close to the mean in this particular case. But in this particular case, the values are very far from the mean, right? So if you look at the extreme values, minimum is 2 and the maximum is 80. Those two values are quite far from the mean, right? So that is the reason why we need measure of spread despite having all these central tendency measures, right? I hope this particular point is clear. So here in this particular case, we can say the values are very much spread or scattered from the mean. And in this case, Samsung's TV sales data, we have all the values surrounded mean, right? So that is the reason why we need measure of spread. I hope this point is clear. Now let's look at each one of spread measures one by one. Let's look at first measure of spread, that is range. So range, it is the simplest measure of dispersion in which we try to find out how much the data is varying, right? So the calculation of range is very simple, guys. Maximum value of your data set minus minimum value in your data set, right? So now if we calculate the range for these two data sets we discussed in the last slide. So here Sony smart TVs, the range value is 18 minus 2. So this is the maximum, this is the minimum. So for this data set it's 16 and for this data set it's 12 minus 8, that is 4, right? So now we can say from the range measure of spread, definitely here we have more scatteredness as compared to this one, right? So range is giving you that indication and that's what we want from measure of spread. Now let's look at another data point, another data set which we used to calculate mean, median and mode in our last video, right? So now in this particular case, for both of them, we have the similar data except one value which we have changed from 90,000 to 9,000, right? So in one case, we have 90,000. So this data was about data scientist salary in Dubai or in dirhams, right? So now here, the range for the first data set is 90,000, that is the maximum value, and the minimum value, that is 6,500. So the final value is coming as 83,500, that is the range value we are getting. Now, in case of second data set here, except 90,000, all other data points are same. Now in this particular case, range is 9,000 minus 6,500, that is 25. Here also, range is actually sensitive to the extreme values, right? So that's what we wanted to infer from this example, that range may be inadequate when looking at larger data sets which having extreme values or outliers, right? Now this is about range, guys. That is our first measure of spread, which is calculated by subtracting minimum value from the maximum value. It's as simple as that. Now let's look at the second most popular. This is the most popular measure of spread we have, that is standard deviation, guys. And let's deep dive into this. So what is this standard deviation? So standard deviation is a measure of how far the numbers are, let me complete this, from the mean value, right? When we will look at the formula of this point will get clear, guys. Here we try to find out how far the numbers are from the mean value. Okay. Now low standard deviation means data points are surrounded or they are very close to the mean value. Absolutely. High standard deviation means points are far from the mean. Low standard deviation means data points are close to the mean. Okay. Now standard deviation is again very sensitive to extreme values, guys. So our measure of spread is very much sensitive to the extreme values, right? A single extreme value can increase the standard deviation. Okay, this is important point. Like range, standard deviation is also sensitive to outliers. Now, if we have the standard deviation equal to 0, it means that all the values are same. If all the values are same, then that value will be equal to the mean, right? And then it means that the difference of xi minus x bar, which we do in the calculation of standard deviation, will be 0. We'll discuss that, guys. Now let's look at the formula of standard deviation and let's try to generate it using our understanding of standard deviation, guys. Right? So let's say we want to calculate the standard deviation for population first. So now important point, guys, as we know, we try to find out the how far the values are from the mean. How can we calculate that? We can calculate that by subtracting mean from every value. Right? Let's say xi is my ith value in the data set minus we have mu, which is the mean of population. We are calculating for the population. Mean of population we represent using mu. Right? So every value will be represented here in the form of xi. Right? Minus mu. Now you will do the square of this. Why we are doing the square? I'll explain that. Now, after that, you will have to perform this operation xi minus mu square of that for all the values. Your values lying from 1 to number of observations in your population, that is capital N. And this value will get divided by the number of observations in your population, guys. And finally, you will take the square root of this. So this is the formula of standard deviation for your population, right? So this is the deviation. This represents the deviation of every value from the mean. You take the square of that and you do this calculation for all the values in your data set divided by total number of observations, square root of that. That is your standard deviation for population. Now, the similar kind of formula we use for sample, except one difference. That is, let's say this is we are doing for the sample. Now everything will remains the same. Here xi minus sample mean we represent using x bar, right? So we will do the square of this. I will be from 1 to small n. Let's say small n is the number of observation in our sample. Now the difference comes in the denominator part. Here rather than having small n, we are having n minus 1. And we take the square root of this. Now one question for you guys, explore it or internet or ask to the chat GPT, right? That why do we have different denominator in case of standard deviation for population and sample? In the standard deviation of population, we have capital N. In case of sample, we have n minus 1. Why that difference is? Just write that in the comment section so that I get to know you are also following me, right? And that will give me the motivation, guys. Definitely in the upcoming videos, I'll explain this part. Why we have the difference in standard deviation of for population and sample. Okay. Now, if this point I was explaining, if all the values are same, then mean will be equal to the values, right? For that particular case, all these terms will be 0, and that will get divided by the number of observation, which will again come as 0. So that is why the standard deviation will remain 0, guys. This is important to remember. If all values are equal, then standard deviation is 0, right? So there is no variation at all. That's why, right? Okay, so now y squared values. This is important to understand, guys. Now I'll explain that with a simple example of this data set. Let's say these are our data points. Blue points represents the different data points. Let's say this is value 5, this is value 10, this is this is, let's say, 15, and this is, let's say, 20, and this value, let's say, I should say this is 10 and this is 5, because this is quite far from the mean, and the, let's say, mean is 12, right? So now if we are using absolute values of the difference, right? So x minus x bar, if we are using this rather than square, what will happen? For the first term, the value is 2, plus for the second term, we have this 12 minus 5, that is 7. Now for the third value, this number will be minus 3, right? Because 12 minus 15, or 15 minus 12, or you can say the reverse part, guys. So here x minus mean, that is 10 minus 12, that is minus 2, right? Similarly, for the second term, it's 5 minus 12, that is minus 7, right? Plus third term, 15 minus 12, that is 3. So what is happening? It will keep on growing, right? So now this value will be minus 6, right? For these three terms. What is happening here? The values, the spread actually getting cancelled out because of positive and negative values. That's why we use square, because we do not want them to cancel out. Because whether it is up or down from the mean, it is representing the scatteredness. We do not want it to get cancelled out. So that is the reason why we use square. No one explained that in these videos, guys. Just go and watch this particular part on YouTube. You can ask this question, you will not find the answer. Right, guys? So follow this particular series. This is the most practical series you will find out, guys. And we will look at how do we calculate this standard deviation, range, variance, all these numbers in Excel on the real world data set. Okay, I hope you are enjoying these kind of discussions, guys. Right? So that is the reason why we use square of the differences. Now one exercise for you, why we use n-1 in case of sample, and in case of population we use n. Why? That you have to write in the comment section, right? If I will get one answer in the comment section, then only I will explain that region in the upcoming videos. Okay. Okay, now let's move to the third type of measure of spread, that is variance, which is quite similar to standard deviation, guys. So variance is the average of squared differences from the mean. It's the same formula we use for variance also, right? The only difference is variance is the square of your standard deviation. So variance is a square of your standard deviation. Now, what is the difference, guys? This is very important point to understand. Why do we need variance if you have standard deviation? There are a lot of reasons. One of the reason is we have variance, guys, we have standard deviation. Let's say if we have data of height, right? Let's say we are calculating what is the average height of Indian. Now for that you have to collect the sample of height of different individuals, and that, let's say, you are calculating in the middle, right? So let's say whatever, let's say in centimeter you are calculating 170, 169, 168, 175, like that. Now for this particular case, if you calculate the standard deviation unit will be centimeter, but in case of variance, the unit will be in centimeter square, right? So sometime when you are representing the standard deviation, it's always better to use standard deviation. But in some calculations, when you are trying to prove something, or in real world when you try to prove a mathematical theorem or statistical theorem or statistical formula, in that case variance is quite helpful, right? So that is a major difference between variance and standard deviation, guys. Now the formula remains the same as we discussed about the standard deviation. You just square the standard deviation, you will get the variance. So in that, difference remains the same, n and n minus 1, guys. Remember this. Okay. So for population, in variance also we will be having capital N as our denominator, and in case of sample it will be sample size minus 1. Okay, so that is variance, guys. We will see how do we calculate that in real world using Excel. We'll come to that point. Okay, so now this is one exercise, guys. I'm not stopping over here. You can pause your video and you have to calculate all these measures which we have discussed so far in for this particular example. So this data represents the temperature in degrees Celsius for last 5 days, and then you have to calculate what is the mean, what is the median, mode, range, standard deviation, and variance. Okay, now the second step, it's very important. Calculate that and write it in the comment section, guys. Answer for these. It will help you to revise all of your data points or all of the concepts which we have discussed so far. Okay, now all these numbers, all these measures, I want to calculate in Fahrenheit also. How that value is changing, right? Just remember the Fahrenheit formula to convert a temperature which is in degrees Celsius to Fahrenheit. This is the formula we use, right? So now you'll have to understand when you are calculating mean, how adding a constant value or multiplying a constant value, the mean will change or median will change or your standard deviation will change. This is very important, guys. Okay, so if you'll do this exercise, at least one answer I want in the comment section, then I'll explain and give you the answer of this, okay, in our upcoming videos. Okay, now the last measure from measure of spread, that is interquartile range. And this is pretty interesting, guys, and we will be using it throughout the statistics. Remember this. So all the measures which we are discussing, those are very important, and throughout this video series I am going to use them. Okay, so before going into the interquartile range, guys, we need to first understand what is quartile. Okay, so what is quartile, guys? Or you can talk about percentile as well, right? So let's say what we do, our data set, we can divide into 3 points, which we call them as quartiles, right? So let's say we have this data point where we have the minimum value, where we have, and here we have the maximum value. Now this complete data we can divide into 4 parts using 3 numbers. Those numbers we call them as quartiles. Okay, like first quartile, this is second quartile, and this one is third quartile. Remember, we are talking about the data set which is arranged in the ascending order. So minimum, then first quartile, second quartile, third quartile, and then maximum value. Right? This is how we can represent our any data set. Right? Now, what is this first quartile? So how do we define this quartile, guys? So let's say if we are talking about first quartile, we says it's a number in your data set on which is having 25% of the data lies below and 75% of the data will lie above this number. So 25% of the observations will lie below this first quartile and 75% of the observations will lie above this first quartile. Similarly, second quartile, we says 50% of the observations will lie below this and 50% of the observations will lie above this, right? And I am pretty sure you know what that number is. There is a specific name to second quartile. That is median, guys, right? So second quartile is nothing but median, because our median divides your data into 50%. 50% of the values lies above the median and 50% of the observations lie below the median. That's how we define median, right? Central tendency median. And the third quartile is nothing but like 75% of the observations will lie below this number and 25% of the observations will lie above this number. That is your third quartile. That's how we define this, right? So first quartile, you can talk about in terms of percentile as 25th percentile. Similarly, second quartile is 50th percentile, which is nothing but median. Now the third quartile is your 75th percentile of the data, right? So this is how we define quartiles. Now if I talk about a data set we have here, right? So interquartile range is nothing but the difference of third quartile and first quartile, right? So generally we write interquartile range as IQR, interquartile range. It's a value third quartile minus first quartile. Okay, so that is your IQR, interquartile range. Okay, so now we will see that in Excel how do we calculate in the next video, guys. Thanks for watching till the end. I hope you understood the different measures we have in measure of spread. In tomorrow's video, we will talk about the third type of descriptive measures we have. Those are shape measures, specifically kurtosis and skewness. Before going into that, we'll talk about histogram and the distributions that will give you a glimpse about the shape of different distributions. So that is important before going into the shape measures, right? So don't miss out tomorrow's video. That is going to be very valuable from the future, specifically statistical inference point of view, guys. Okay, so thanks again. See you tomorrow, guys. By that time, take care and keep learning.